Congratulations! You've made it to the end of Chapter 3. This video will help you prepare for your Chapter 3 test. So not only will this help you do better on the test, but you will actually get points for watching this video. In order to earn the points, you need to write down the answers to the 4 highlighted questions and submit them to this assignment form. There'll be additional problems, but you only have to do the 4 that are numbered and highlighted. Write down the steps and submit. The first thing that we learned about in Chapter 3 were parallel and perpendicular lines. Parallel lines are 2 lines that never intersect. We can show that they're parallel with drawing arrows on the lines. Perpendicular lines intersect at right or 90-degree angles. This is a pretty common angle. We can show it by drawing the little square in the corner where the lines intersect. There are many lines that are neither parallel nor perpendicular. So if the lines cross, they're not parallel. But if they don't meet at right angles, they're not perpendicular either. A common place that you'll see parallel and perpendicular lines is on a map. So we're going to look at this map and just based on appearance, decide if the streets are parallel, perpendicular, or neither. Let's start with Capitol and Meridian. I've highlighted Capitol and Meridian Street. Take a moment to decide if those lines appear parallel, perpendicular, or neither. Hopefully you can tell that those 2 streets are parallel. If they continue straight, they are never going to intersect. Our next pair of lines are Senate Street and Indiana. You should notice right away that Senate and Indiana intersect. Since they cross, we know they can't be parallel. However, they don't intersect at a right or a 90-degree angle, so that means they're not perpendicular either. Senate and Indiana are neither parallel nor perpendicular. Our last pair of streets are Vermont and Pennsylvania. Vermont and Pennsylvania intersect. They intersect at a right or a 90-degree angle. That means that they are perpendicular. Let's do another set of identifying parallel and perpendicular lines. You'll notice that this is highlighted in the top at yellow. That means that you should write down your answers to these 3 problems. So this is problem number 1. We're going to name parallel and perpendicular lines. First off, a reminder that lines are named with 2 capital letters. So when you name a line, you will use 2 capital letters. Each of those letters should be a point on the line. 1A, name of pair of parallel lines. Okay, again, remember that parallel lines never intersect, and they're shown to be parallel with the little arrows drawn on the lines. So I'm going to go ahead and highlight the lines that I believe are parallel. Now, once I've picked them out, I need to name them. Again, I'm going to name each line with 2 capital letters or 2 points. There's actually more than 2 points on each of the lines, but I only picked 2 of them. So for example, I can name this first line, using those 2 points. So I'm going to call that line GB. Now I'm going to find a name for the second line. Again, I'm going to pick 2 points from that line. I'm going to pick E and C. So I can call that second one line EC. So line GB and line EC are parallel. That's not the only correct answer, because remember, I can use a different name for each of those lines. I could pick different points from each line. So I could say line FB is parallel to line HC. There is more than one correct answer. In 1B, we need to name a pair of perpendicular lines. To find perpendicular lines, we're going to look for the angles that have this little square mark. Notice that means that those intersect at 90-degree angles. So this happens in two spots. So again, we have a couple choices, but both of the choices are going to use this line. So I know for sure I'm going to use that line that I highlighted in blue. And now I have two options. Pick one of them. Okay, so the blue line and the orange line are perpendicular. We need to name them. So just as we did before, we're going to pick 2 points from each line. Remember, there's more than one option. So I'm going to start with the blue line, and I'm going to use that one and that one. So I'm going to call the blue line, line AD. Now I need to name the orange line. We already named this line in the past, so if you remember from 1A, or again, we're going to pick 2 points from that line. I'm going to pick GB. Line AD and line GB are perpendicular. Now again, there's multiple answers. I could have used the bottom line, HC, or remember, instead of AD, I could have called it AE. So lots of options. Finally, we need to name a pair of lines that are neither parallel nor perpendicular. So I'm going to look for a pair of lines that cross, but not at a right angle. And again, I have multiple options, but they are all going to use that line I just made in green. So I notice that those lines cross, but there's not a right angle symbol. So now I'm going to go ahead and name them. I'm going to pick 2 points from each line. So from the green line, I have G. And over there, underneath my highlighting, that's C. So the green line is line GC. Now we'll look at the pink line. Notice point C is also on that pink line, so I can use that. And I just need one other point. So I'm going to take E. And therefore, I'm going to call that pink line, line CE. So line GC and line CE intersect, but they're neither parallel nor perpendicular. Again, to get your points for this video, you must write down your answers for all of number 1. If you haven't done that, go ahead and pause the video and make sure you wrote down your answers clearly and labeled them. When we have parallel lines and another line intersects them, we have special names for the types of pairs that are formed. And the thing about these pairs is they give us equal angles or supplementary angles depending upon the type. The first thing is to make sure you can identify the types. Let's start with alternate interior angles. These angles are on opposite sides of the transversal. That's the line that crosses the other two. They're not next to each other, and they're in between the two parallel lines. So on our picture, angle 2 and angle 8 are alternate interior angles. If I wanted a second pair, angle 3 and angle 5 are also alternate interior angles. Closely related to this are alternate exterior angles. The key here is that they're going to be exterior or outside of the two parallel lines. Again, they're on opposite sides and they're not next to each other. Our first pair is angle 1 and angle 7. Notice how they're both outside the lines. One's on the left, one's on the right. The angle in the bottom left, that's marked 65 degrees, is an alternate exterior angle with angle 4. Corresponding angles are on the same side of the transversal. They're not next to each other, and one is inside and one is outside the parallel lines. While we had 2 pairs of the interior and alternate exterior, there's actually 4 pairs of corresponding. Let's find a couple. So angle 4 and angle 8 are the first pair. Notice angle 4 is exterior, angle 8 is interior, and they're on the same side. Angle 3 and angle 7 are also a corresponding pair. They're both on the right. 3 is inside and 7 is outside. Same side interior angles. As the name implies, they're going to be on the same side of the transversal. They're not next to each other, and they're in between the 2 parallel lines. So angle 2 and angle 5 are both interior on the same side. They don't share a vertex. The other pair is angle 3 and angle 8. Our final angle pair are same side exterior angles. These will be 2 angles that are both outside the lines. They'll be on the same side. So angle 4 and angle 7 are same side exterior angles. They're both on the right. They're both outside the parallel lines. In this question, let's identify what kind of angle pair we have. So the first question wants us to look at angle 3 and angle 5. I usually start by asking myself if each one is interior or exterior. Okay, angle 3 is in between the 2 lines. So angle 3 is interior. Angle 5 is also in between the 2 lines. That means it's interior. Now I'm going to look at if they're on the same side or the opposite side. I highlighted the transversal in pink, and hopefully that helps you see that angle 3 and angle 5 are on the same side. So angle 3 and angle 5 are same side interior angles. Our next set is angle 4 and angle 8. So angle 4 is interior. It's in between the 2 parallel lines. Angle 8 is exterior. And they're both on the right side of the transversal. So this is the one that's a little bit different. When I have one interior and one exterior on the same side of the transversal, those are called corresponding angles. How about angle 3 and angle 6? Take a minute to think about that one on your own. We've already identified that angle 3 was interior. Angle 6 is also interior. They're on the opposite side of my transversal. So that means we have alternate interior angles. And now our final example, angle 2 and angle 7. Angle 2 is an exterior angle. It's above the parallel line, whereas angle 7 is below the parallel line. They're outside of it. So those are both exterior angles. They're on the opposite side. This means that angle 2 and angle 7 are alternate exterior angles. Now, you might wonder why that matters. The reason it matters is that when the lines are parallel, These angles have a special relationship. That means that if we know just one angle, we can actually find all the other ones, and we'll just have two different numbers as our answers. We have multiple types of angle pairs that are equal. So alternate interior angles, alternate exterior, corresponding, or vertical angle pairs all create equal pairs of angles. Linear pairs, same side interior or same side exterior angle pairs, are supplementary. In order to find that, we subtract from 180. So you'll notice in my example, I have multiple angles that are 130, and then the other ones are 50. 130 plus 50 is 180. Let's do another problem that you should write down. So on your paper, let's do number 2 together. We're going to find the missing angle measurements. You'll notice we were given one angle. We're told that this angle over here is 107. Now, there are lots of different ways that people start this. What I suggest is that you start by finding angles that you know will be equal to that angle. The one most people start with is actually this. Angle 7 and the 107-degree angle are vertical angles. Vertical angles are equal. So I know that angle 7 must be 107 degrees. Even if I don't use the new formulas, I can find the measure of angle 6. Angle 6 forms a linear pair with the 107-degree angle. Notice that they're adjacent angles, and their bottoms make the straight angle, or that straight line. So that means they have to add together to equal 180. So angle 6 is going to be 180 minus 107, which is 73. Take a moment to think about how we can find angle 8. Angle 8 is a vertical angle with angle 6. That means that those are equal. It's also a linear pair with 107. So it would subtract from 180. 180 minus 107 would give us again angle 8. Once you have all four angles at the top done, now we have to figure out something to get us down to the bottom. Again, there's different ways to do this, depending upon what kind of pair you're most comfortable finding. You'll notice I have a mark in the 107 and the angle 12 down here. Those are alternate exterior angles. I know that alternate exterior angles are equal when the lines are parallel. So angle 12 also needs to be 107. So again, there's multiple ways to do this. You could find alternate interior pairs or corresponding pairs, but most people, again, work with vertical angles. So angle 12 and angle 10 are vertical angles, so those are equal. I'm still missing angle 9. Again, a couple ways you could think about it. I know that angle 9 and angle 12 have to add together to equal 180. Or I could realize that 8 and 9 are alternate interior angles. So 8 and 9 would be equal. So angle 9 is 73 as well. That leaves one angle left. Angle 9 and angle 11 are vertical angles, so those are equal. Angle 11 is also 73 degrees. Notice that all of our answers are either 73 or 107. Also, if I add the two different numbers together, they equal 180. Now we're going to move from parallel and perpendicular lines to coordinate planes. We're going to start by looking at points. Points can be identified by ordered pairs. The coordinates tell where that point is located. In an ordered pair, the distance right or left always goes first, and the distance up and down goes second. And we count those distances from the origin, or point here, 0, 0. So as we identify the coordinates, let's actually start with B. So B is the origin. Notice it's where the two darker lines intersect. So B has coordinates 0, 0. Now let's look at A. So remember, we start by counting left from the origin. So I'm going to move over 1, 2, 3. I'm just counting boxes, but I can also tell that over here is -5. Okay, so I moved left 3. Since I moved left, my x-coordinate is -3. Then I count how far up I moved. So from the origin, I had to go up 1, 2. Up is positive. And the coordinates of A are -3, 2. Let's try C. C is over 1, 2. So x-coordinate is 2. C is up 5. Again, I can count, or I could look at the x-axis or the y-axis and notice, well, here's 4, here's 6. C is right in between there at 5. And finally for D, I'm going to move right 4. And then I count down 1, 2, 3. Right 4 is +4, comma, I'm down 3. I write that as -3. So D is at 4, -3. Now let's look at slope. Slope of a line is the steepness and direction of a line. We write slope as a fraction, rise over run. But first, let's start by just looking at the pictures. Slope can be positive. So if it looks like it's going uphill, it gets higher to the right. That's a positive slope. Downhill, where it gets lower to the right, has a negative slope. Horizontal, straight across, has a slope of 0. And a vertical line has an undefined slope. We can start by finding slope on a graph. To find the slope on the graph, we're going to count the distance between the points, straight up or down, and straight right or left. The key when we count is to make sure that you start counting at 0. You're counting the total number of squares. We're going to put the distance up or down on the top of a fraction, left and right on the bottom. Let's try one. I want to find the slope of AC. That means I'm going to start at A and I'm going to count up till I get to the same height as C. Notice at A, this is 0, but there's 1 square, 2 squares, 3 squares. So I went up 3. That goes on the top of my fraction. Now I'm going to count over to C. So I'm starting here and I'm counting how far over. 1, 2, 3, 4, 5. Again, I'm counting total squares. So I counted up 3 squares, over 5 squares. Slope is a fraction, 3/5. Let's find the slope of BD. So I'm going to start at B. I'm going to count the distance down to D. So B, I'm going to go down 1, 2, 3. Since I went down, that's considered negative. So I'll put -3 on the top of my fraction. Now I'm going to count over. 1, 2, 3, 4. There were 4 squares. It was right. That's positive. So that one has a slope of -3/4. Notice it's negative because it's going downhill to the right. We can also find slope if we don't have a picture. There's a formula. To find the rise, we subtract the y values. Put that on top. We subtract the x values and put that on the bottom. And it's okay to use your calculator because you might end up with negative answers. So this is question number 3 that you should be writing down. Let's start by subtracting the y values. Remember, the y values are the second numbers in each of your coordinates. So I have a 5 and a 14. So on the top, I'm going to take 14 minus 5. Again, you can go ahead and use your calculator. 14 minus 5 is 9. That's the top of my fraction. Now I'm going to look at the x coordinates. The x coordinates are 18 and 10. Here, the order is important. Notice I started with 14. That means I also have to start with 10. So I'm going to take 10 first, minus 18. You'll notice the first number is smaller than the second one. That means we're going to get a negative answer. So again, don't be afraid to use your calculator. 10 minus 18 gives us a value of negative 8. So negative 8 goes on the bottom of my fraction. That means that the slope, I can write it with a negative out in front. It's negative 9/8. Let's combine those last couple skills we learned. We're going to talk about slope and parallel and perpendicular lines. So parallel lines have equal slopes. The slopes are the same. The slopes of perpendicular lines are negative reciprocals. A negative reciprocal means we flip the fraction and we change the sign. Let's look at an example. We are told that a line has a slope of 5/4. What's the slope of a line parallel to this? Well, remember, parallel lines have equal slopes. So the slope was 5/4. A line parallel to that is going to have the same slope. So the parallel line would have a slope also of 5/4. What is the slope of a line perpendicular to this line? Well, perpendicular lines have slopes that are negative reciprocals. So again, a negative reciprocal, first off, means I'm going to flip the fraction. So before it was 5/4. Now it's going to become 4/5. And negative means to change the sign. So negative 4/5. Now, if we start with one that's negative, the reciprocal, the negative reciprocal would be positive. So our answers will always be one that's positive, and the perpendicular will have one that's negative. So one positive and one negative for perpendicular lines. We are at our last skill. This is also the last problem you'll write down. So the last thing we learned was midpoint. Midpoint is in the middle. In order to find the midpoint, we have a formula that we can use. What this formula means is that we'll add the x values and divide by 2. Then we'll add the y values and divide by 2. Our answer is a point, so it's written as an ordered pair. So our question says, what is the midpoint of 12, 5 and -2, 7? Start by identifying the x values. So my x values are 12 and -2. So the first thing I'm going to do is add 12 plus -2. If you have a negative number, you might want to use your calculator. It might vary how you do this on your calculator. 12 plus 2, and then I'm going to put the plus minus key so I can make that 2 a negative. So 12 plus -2 equals 10. Okay, so I added the x values. Now I divide that by 2. So 10 divided by 2 is 5. 5 is going to be the first coordinate of my midpoint. Now we look at the y values. That's the second number in each set. So first I add the y values. 5 plus 7. 5 plus 7 is 12. I divide that by 2. 12 divided by 2 is 6. That's my y coordinate. So my midpoint is at 5, 6. I hope that this video helped you feel more prepared for the test. Remember, in order to earn your points, make sure you wrote down your answers to those 4 highlighted questions and submit it. I hope that you do well on the test. I'm confident that you can do this.